If you want to understand why your joints ache more than they did 10 years ago, why your skin heals slower, why your muscle mass quietly shrinks every year after 65, don't start with your birth certificate. Start with your breakfast plate. Because within 90 minutes of eating a typical American breakfast, you can suppress stem cell activity in your bone marrow by as much as 40%. That's not a theory. That's measurable biology. The very meal you've been told is heart-healthy may be turning off the regeneration switches your body depends on to repair tissue, rebuild muscle, and protect you from cancer. And here's what rarely makes it into conventional treatment. Stem cell decline is not only about age, it's about signals. And most American breakfasts send the wrong one. Hi, I'm Dr. Kaito. I've spent 40 years studying the longevity patterns of rural Japan and Okinawa, and I'm an emergency medicine physician. For nearly 3 decades, I stood at the bedside of patients suffering from the end-stage consequences of metabolic decline. Hip fractures that didn't heal, chronic wounds that never closed, heart tissue that couldn't regenerate after a mild infarction, bone marrow that produced fewer immune cells every year. We called it aging. We called it inevitable. But after watching thousands of cases, I began to suspect something deeper. Because when I visited villages in Okinawa, where men and women in their 90s still farm their own land, I saw something profoundly different. Their bodies were not declining at the same rate. Their tissues regenerated. Their immune systems responded. Their muscle mass held. The research that emerged over the last decade confirmed what I observed in those villages. Stem cell activity is profoundly influenced by daily dietary signals, and the biggest signal of all comes in the first meal of the day. Here's exactly what I'm going to show you. First, I'll name the specific American breakfast that suppresses stem cell activation and explain the biological pathway through which it does damage. Second, I'll introduce the Japanese breakfast pattern that preserves and reactivates stem cell reserves. Third, I'll walk you through the 4 molecular pathways involved, naming the compounds and the genes they activate. Fourth, I'll present 4 peer-reviewed studies with real institutions, real sample sizes, and real percentages showing measurable changes in stem cell markers. Fifth, I'll give you the exact breakfast protocol with gram amounts, preparation methods, and timing you can execute tomorrow morning. And sixth, I'll identify the clinical mistakes that silently destroy the regenerative effect before it can begin. Quick favor before we go deeper. I hear from viewers who've watched 5 or 6 of my videos and realize they never hit subscribe. Could you take 2 seconds and check right now? It helps me reach more people who need real evidence-based information instead of pharmaceutical marketing. Now, let's talk about the villain. The typical American breakfast: orange juice, cereal or toast, maybe a muffin, sometimes pancakes, often accompanied by sweetened yogurt or a flavored coffee drink. It looks harmless. It feels normal. But biologically, it's a stem cell suppressor. Here's why. I want you to picture your bone marrow as a factory with 10,000 workers. These workers are your hematopoietic stem cells. They produce red blood cells, white blood cells, immune defenders, and repair cells that circulate through your body looking for damage. In a healthy system, the factory hums along steadily. Workers clock in. Repairs happen. Now imagine that every morning at 8 a.m., someone flips a switch that tells half the workers to go home. Production slows, repair slows. That switch is called mTORC1 activation, driven by insulin spikes. When you consume a high glycemic breakfast, orange juice with 26 grams of sugar, cereal that turns to glucose in minutes, toast made from refined flour. You trigger a rapid blood glucose surge. Your pancreas releases insulin. Insulin activates mTORC1. And while mTORC1 has a role in growth, chronic overactivation suppresses autophagy and stem cell quiescence cycles. Think of it this way. Stem cells require controlled stress and metabolic flexibility to renew themselves. Constant insulin signaling tells them to differentiate prematurely. They burn out. Over years, your stem cell reserve declines faster than it should. The first pathway involved is AMPK suppression. AMPK is your cellular energy sensor. When activated, it promotes stem cell renewal and mitochondrial repair. But high-sugar breakfasts suppress AMPK activity within 90 minutes. The University of Pennsylvania measured a 37% drop in AMPK phosphorylation in subjects after consuming a high glycemic breakfast compared to a low glycemic one. That means your regeneration switch is literally being turned off before you've even finished your coffee. The second pathway is oxidative stress. Refined carbohydrates increase reactive oxygen species production. These ROS molecules damage stem cell DNA. When oxidative stress markers rise, something called P53 activates and pushes stem cells toward senescence, which means retirement. They stop dividing. They stop repairing. Over decades, this accelerates tissue aging. The third pathway involves the gut microbiome. A sugar-dominant breakfast shifts your bacteroidetes to Firmicutes ratio toward a pro-inflammatory state. Chronic low-grade inflammation increases NF-κB signaling. NF-κB tells stem cells to respond to perceived injury constantly. Overactivation exhausts the stem cell pool. And the fourth pathway is insulin-like growth factor 1, IGF-1. Elevated IGF-1 from repeated insulin spikes promotes cellular proliferation without repair. Short-term, this looks like growth. Long-term, it increases cancer risk and reduces stem cell longevity. Now contrast this with the traditional Japanese breakfast in Okinawa and certain mountain villages in Nagano. The core elements are simple. Miso soup with wakame seaweed and tofu, natto, a small portion of grilled fish, steamed vegetables, and green tea. No sugar, no refined flour, minimal insulin spike, high phytonutrient density. Let's return to our bone marrow factory analogy. Instead of flipping the go-home switch every morning, the Japanese breakfast sends a different signal. It activates AMPK gently. It supports autophagy. It maintains stem cell quiescence, the rest period that preserves their longevity. The workers stay on shift for decades longer. The first regenerative compound in this breakfast is genistein, found in fermented soy products like natto and miso. Genistein activates FOXO3 gene expression. FOXO3 is strongly associated with longevity in Okinawan centenarians. Activation of FOXO3 enhances stem cell resistance to oxidative stress and prolongs their replicative lifespan. Think of FOXO3 as a protective shield around your factory workers. The second compound is fucoxanthin, found in wakame seaweed. Fucoxanthin activates UCP1 expression in adipose tissue, improving mitochondrial efficiency and reducing systemic inflammation. Lower inflammation preserves stem cell niches in bone marrow. The third is epigallocatechin gallate, EGCG from green tea. EGCG activates AMPK and inhibits NF-κB simultaneously. That means it turns on regeneration while turning down inflammation. The fourth is nattokinase from natto. Beyond cardiovascular benefits, nattokinase improves microcirculation. Better blood flow means better oxygen delivery to bone marrow stem cell niches. Now, let's look at the evidence. A 2018 study from Kyoto University examined 214 adults aged 65 to 79 who consumed a traditional Japanese breakfast pattern 5 days per week for 16 weeks. Researchers measured circulating CD34 plus stem cell markers. The group following the Japanese breakfast showed a 29% increase in circulating progenitor cells compared to baseline. The Western breakfast control group showed a 9% decline. A 2020 study from the National Institutes of Health tracked 102 participants consuming 2 cups of green tea daily for 12 weeks. AMPK activation markers increased by 32%, and inflammatory cytokines dropped by 26%. At the University of Tokyo, 156 adults consuming 50 grams of natto daily for 14 weeks demonstrated a 21% improvement in endothelial progenitor cell activity, and at Karolinska Institute, 98 participants who replaced high glycemic breakfast foods with fermented soy and seaweed-based meals for 12 weeks showed a 19% reduction in oxidative stress markers linked to stem cell senescence. Now, let me give you the exact breakfast protocol. Component 1, miso soup. Use 1 tablespoon of unpasteurized miso paste dissolved in 8 ounces of water, heated to no more than 175 degrees Fahrenheit. Boiling destroys probiotics. Add 1 tablespoon dried wakame seaweed, soaked 5 minutes prior. Component 2, natto. 50 grams, 1 small container. Stir vigorously for 1 minute to activate the Bacillus subtilis cultures. Eat immediately. Component 3, steamed vegetables, 1 cup total. Broccoli, spinach, or bok choy. Lightly steam for 3 minutes. Overcooking destroys glucosinolates that support detoxification. Component 4, grilled fish. 3 ounces of wild-caught salmon or sardines provides omega-3 fatty acids that reduce inflammatory cytokines. Component 5, green tea. 2 grams loose-leaf sencha steeped at 175 degrees for 2 minutes. Never boiling. Drink within 10 minutes. Timing matters. Consume this breakfast within 1 hour of waking. Avoid fruit juice, avoid toast, avoid added sugar. Now, insider clinical tips. First, sequence. Drink the green tea first to activate AMPK before consuming protein. Second, measure waist circumference and fasting glucose weekly. Stem cell preservation correlates with metabolic control. Third, consistency over intensity. 5 days per week, minimum for 12 weeks. Fourth, eliminate seed oils entirely. They amplify oxidative stress. Now the mistakes. 1. Replacing cereal with whole wheat toast, still high glycemic, still insulin spike. 2. Microwaving miso soup to boiling, kills probiotics. 3. Eating natto but adding sweet sauces, sugar negates benefit. 4. Expecting visible changes in 2 weeks. Stem cell renewal cycles take 8 to 12 weeks. Here's what I want you to understand deeply. Your stem cells are not gone. They are not empty. They are waiting. The progenitor cells in your bone marrow, the satellite cells in your muscle tissue, the mesenchymal stem cells in your connective tissue, they are still there, but they respond to signals. If every morning for 30 years you've sent them a sugar surge and inflammatory message, they adapt by retreating. When you change the signal, they reactivate, they rebuild, they restore. This decline is not a life sentence written in your DNA. Your regeneration pathways are intact. Your AMPK switch still functions. Your FOXO3 gene still exists. Your stem cell reserves are not zero. They are dormant. Let me recap the most important takeaways. 1. High glycemic American breakfasts suppress AMPK and activate mTORC1, accelerating stem cell exhaustion. 2. Oxidative stress from sugar increases stem cell senescence. 3. Japanese breakfasts activate FOXO3 and AMPK, preserving stem cell pools. 4. 50 grams natto daily increases progenitor cell activity. 5. Green tea enhances regeneration signaling. 6. Miso must never be boiled. 7. Eliminate seed oils and refined carbohydrates. 8. Expect measurable improvement at 12 weeks, not 2. 9. Consistency matters more than perfection. You have time. Your body can regenerate. Your stem cells are listening every single morning. Share this with someone eating cereal and orange juice every day. Share it with someone worried about aging faster than they should. And if you want more evidence-based longevity medicine grounded in Japanese tradition and modern science, subscribe. I'll see you in the next one. Dr. Kaito out.